Okay, we're going to do 8-6B. This is the last lesson of the chapter. We have a quiz coming up, and we'll review before the quiz. So we're going to do solving equations day 2. They're going to get a little tougher today, and we're going to do some applications of these. In other words, word problems. Yes. All right, so 2 parts. Part A. Here we go. We're still going to either multiply by the LCD or cross multiply, depending on the problem, okay? So it's the same thing that we did yesterday. It's just our problems are going to be a little harder now, all right? So here we go. Number 1. Suppose that we have 4 over x minus 2 equals x minus 1 over x minus 2. Now, you can do this one a couple of different ways. You can look at this and go, well, the fractions are going to be equal to each other, and their denominators are already equal, so all I have to do is really set the tops equal to each other and solve. It's true. That's all you have to do. If you cross multiplied here, you'd have to FOIL and do a whole bunch of stuff, and then you'd get some answers that aren't going to work, actually. So what I would do is tell you to just kind of stand back and look at this, and you have 4 has to equal x minus 1, because the denominators are exactly the same. So let's just set that up. 4 is going to equal x minus 1. And then add 1, so x would be 5. Okay? If you cross multiplied, you'd still get 5, but you'd also get a number that doesn't work. We can do that if you want to, but I thought shortcuts are kind of nice too. All right, the next one's not going to have a shortcut.
That's all you do?
Yeah. Number 2.
We were going to go with quiz. Yeah.
For now, that's how you do it.
Maybe. You don't like that one?
I do.
Oh, you do? Oh. Okay, here we go, number 2. Suppose now that we have this problem. 2x plus 1 over 6 plus x over 2 is equal to x minus 1 over 3. All right, so no shortcuts on this one. We're going to have to actually do the whole thing. And let me show you how to do this problem, okay? We're going to multiply everything through by the LCD. And what would that be? 6. Perfect. You guys are getting really good at figuring that out. Now, here's my suggestion to you. When you take this 6, and this is really 6 over 1, and we're going to take this and multiply it in, you're going to multiply all of the numerators. When you do that, don't distribute, though. Okay? I'll show you why. So 6 times 2x plus 1 is 6. Nope, don't distribute. It's 6 times 2x plus 1. I'll tell you why in just a minute, okay? Plus 6 times x is just 6x over 2 equals 6 times x minus 1 over 3. You're very tempted to distribute, but I'm telling you not to because you're actually going to reduce. And in order to reduce, you want factors. So why would you distribute when you actually then will have to factor?
We have done this in the last lesson.
We did this type of thing in the last lesson. These are a little bit harder. Yeah. Okay, so now let's go ahead and reduce these. 6 and 6 reduce, leaving us with 2x plus 1. Over here, 6x over 2 is what? 3x. And over here, 3 goes into 6 how many times? 2. And so then I get 2x minus 2. So you want to, get rid of your fractions. You don't want to distribute yet. Now you get to have something like that to solve. And that's not so bad, right? 2x plus 3x make 5x plus 1 equals 2x minus 2. Subtract 2x to the other side. Okay, so you get 3x plus 1 equals negative 2. Subtract 1 to the other side. So x equals negative 1. Nice, huh? And it's just a little teeny bit harder than yesterday. And it's the same kind of thing. You have to multiply everybody by something, but then it's the reducing. Okay, let's do number 3 now. I've got 2 more of these, and then I have 3 word problems with you today. All All right, number 3.
Number 3.
We have 2 over n plus n plus 2 over n plus 1 equals negative 2 over n squared plus n. All right, write that down and I'll wait for you. Here we go. So most of the things we've been doing, you know, the least common denominator has been pretty easy to see. So what you have to do for this one is you have to factor. See this right here? That's factorable. So I'm going to rewrite this problem as 2 over n plus n plus 2 over n plus 1. None of those can be factored. But over here, this is n times n plus 1. It's important to see that. Okay, now we're ready to clear our fractions by multiplying both sides of this equation by the LCD. What is the LCD in this problem? We need an n and an n plus 1. Okay? So we need this factor right here, this n. We need an n plus 1, and this one has both of them in it, so we're ready to go. Okay? Now, here's what you're going to do. You're going to take this, which is over 1, you're going to distribute it to all of the numerators. But do not multiply and FOIL and do all that stuff. Just put it on top next to them, right next to them, okay? So here we go. We've got 2, bless you, times n plus 1, and this is over n. So I'm taking this in red, what I have right here, and I'm multiplying it times the numerator. Plus, I have n plus 2 times n plus 1 all over n plus 1. So I just wrote these two things right next to it because they're all being multiplied together. Equals negative 2 times n plus 1 over n times n plus 1. Is everyone okay with that step? I mean, basically all you're doing is taking this n times n plus 1 and putting it next to all of the numerators. That's all you're doing. Now here comes the fun part. I know this doesn't seem fun, but it is.
Always fun.
We're going to clear all these fractions that we have here. Okay? So the n's reduce, leaving us with 2n plus 2. Over here, what reduces over here? Yes, I have an n plus 1 and an n plus 1, leaving me with n times n plus 2, which gives me n squared plus 2n, equals, on this side, I have some things that I can reduce. The n's reduce, and the n plus 1's also reduce, leaving me with negative 2.
So now you distribute it.
Yes, yeah. I didn't have to in that step. It's just I kind of, you know, didn't want to rewrite it and rewrite it again. Okay, now we're solving this equation, and it's a quadratic. We're solving this quadratic. So what we want to do is bring everybody over to the n squared side. So I've got an n squared, and I have a 2n plus another 2n gives me 4n. And then I'm also going to add this 2 to the other side, which will give me plus 4. Okay? Now, I usually will make these so that they work out nice. They're nice and factorable. What times what's 4 adds up to 4? 2 and 2, right? And so I get that the answer would be n equals negative 2. Isn't that so good? Look at that whole problem.
Actual hell.
This is actual hell?
Yeah.
No, this is called math class. All right. That's pretty good, though. So what would make this 0 would be negative 2 and negative 2, so I get it twice. Yeah, our answer is n equals negative 2. All right, let's do one more of those. These are tough. I agree. Number 4. All right. X over x minus 3 plus x over x plus 3 equals 2 over x squared minus 9. I love this one. Such a good problem, too. Okay, are you ready? Well, the first thing you need to do is you need to figure out what the LCD is. So you clear everybody. So we really need to factor that, okay? And you know how to factor pretty good by now, right? So this one right here is the difference of two perfect squares. So it's going to be x plus 3 and x minus 3. Yes? Feel pretty good.
Rewrite the whole thing every time.
Yeah, you know, if you got this problem in your book, like you looked at this problem, I would probably go ahead and write this step right here by factoring, so I didn't have to write it down twice, like, you know, because it's a lot when you do that. Now let's multiply both sides of our equation by what? X plus 3 and x minus 3. Okay, we need an x minus 3 from here. We need an x plus 3 from there. We need the whole thing, which we have. So let's do it. We're going to take this, and we're going to multiply all of our numerators by that. Okay, so I've got an x, and now I've got an x plus 3 and an x minus 3 with it. And this is all over x minus 3. So that's our first equation, our first expression, a rational function expression. And you write it like that. The next one, same thing. It's x times x plus 3 times x minus 3 all over x plus 3 equals. Finally, we have 2 times x plus 3 times x minus 3 all over. See, you notice how none of the denominators change. Bless you. We're not multiplying any of the denominators by really anything. This is x plus 3 times x minus 3 all over 1, so you're multiplying all the numerators and none of the denominators. And now we get to reduce. This is the fun part, yeah? You like this part? It is.
My hand is cramped.
Already?
Yep.
Well, we're only halfway done.
I have weak hand muscles.
Oh, okay. So the x minus 3's reduce, leaving us with x squared plus 3x. Everyone's okay with that first one? Yeah? The next one, the x plus 3's reduce, leaving us with x squared minus 3x. Ooh, it's getting good. And then over here, equals, oh, here's the good part, right? The x plus 3's and the x minus 3's. Everybody reduces, leaving us with just 2. Yes. All right, so what do we get? Well, let's combine our like terms. An x squared and an x squared give us 2x squared. A 3x and a negative 3x cancel out, equal to 2. Do you know how to solve something like this?
No.
Yeah. We learned this. Yeah, divide by 2. Perfect. And then take the plus and minus square root. So you get plus or minus 1. So good. That was a good one. That's probably my favorite problem of the day, really. Okay, now I'm going to give you a little handout, and we're going to do 3 problems on there. We've got 3 word problems to do. So let's start. Number 1. This is on your worksheet that I just handed out, so I'm not going to write the whole thing down. I'm going to write mostly the answers. It says here, if it takes Caden 3 hours to do a job, what part of the job can he do in 1 hour? So it takes him 3 hours. 1/3, right? Okay. So 1/3. How about in X hours? X thirds. X thirds, such a weird thing to say, right? Now, if it takes Andrew, who's younger than Caden, Caden's my sister's son, Andrew's my son. If it takes Andrew 4 hours to do a job, what part of the job can he do in 1 hour? 1/4, x over 4. Now, here's what we're going to do. Suppose that they work together on this job. How long will it take them working together? So this is what you want to do. Here's Caden, and here's Andrew.
California.
Okay? And separately, Caden can do the job in 3 hours, and Andrew can do it in 4. And then together, they can do it in X hours. So this is what you want to do. You want to set these up all this way. It's really great. You're going to have Caden x over 3 plus Andrew working with him, x over 4, and this is going to equal 1 full job done. These are always equal to 1. These are so cool. Okay? And so now we're going to solve that. And in order to solve that, you need to know how to do, multiply through by the LCD and all that stuff. So what are we going to multiply everybody by? 12. Good. 12. Okay? So 12 gets multiplied here, there, and there. So we get 12x over 3 plus 12x over 4 equals 12. Let's go ahead and reduce, because the reason why we multiply by 12 is so that we can clear our fractions out of there. So we get 4x plus 3x equals 12. And that makes 7x equals 12. And then divide by 7. 12 divided by 7, hold on, is 1.7 about. So working together, it's going to take them 1.7 hours. See, and this is all about teamwork. I know. Caden, it would take him 3 hours by himself. Andrew, it would take him 4. But they work together, and it takes them less than 2 working together.
Teamwork is the teamwork.
Beautiful, huh? Okay. Let's do number 2. This is an actual problem that happened in real life. It actually did. So a father and a daughter painted a bedroom in 6 hours. That would be my dad and myself. We painted my bedroom. Dad said he would have taken 8 hours working alone, a painter by profession. He painted in the summer when he wasn't teaching. Then Cameron, that's my sister's little girl, but it should be me, but wondered aloud, how long would it take me to paint the room by myself? And the father reminded her that he paid a lot of tuition to send her to Valley, and having taken Algebra 2, she should be able to work that problem out.
Oh my gosh.
Yeah, for reals, though. Dad, she said, like that was last year. But he encouraged her to write down the information, set up an equation, and she did, and had her answer in no time at all. So here we go. Here's the dad, and here's Cameron, okay? And separately, they can do separate. I always spell separate wrong. Is that how you spell separate? Is that an E? Okay, got it. Separately, Dad can do the job in 8 hours, right? Cameron, she can do the job in X hours. We don't know. We don't know how long Cameron could do this painting job. But together, that's over here, they can do the job in 6 hours together. Okay, so they can paint this room together in 6 hours. So this is what you want to do. You want to take together over what the dad can do, plus together over Cameron's job, and this is going to equal 1 full job done. Okay, you always set these up this way. Together over separate plus together over separate equals 1 full job. The 6 was right there at the first sentence. A father and daughter painted a bedroom in 6 hours. Yeah. All right, so now let's multiply everything through by 8x. You are correct, 8x. Okay, so we get 48x over 8 plus 48x over x equals 8x. Okay, so 48x over 8 is what? 6x plus 48 equals 8x. Subtract 6x over to the other side. You guys are good at solving from here, I hope. 48 equals 2x. Wow, it would take Cameron how long? 24 hours working by herself to paint that room. She didn't help out much, did she? Well, seriously though, if you look, the dad can do it by himself in 8 hours. Together they do it in 6. She's not really helping that much, is she? Yeah, she's kind of causing problems is what she's doing. Okay, and finally the last one. This one's probably my favorite. You would think number 2 would be, but it's not. My dad and I actually painted my room together, and he actually made me solve that problem. Okay, number 3.
I painted my pastor's house.
How was it? Painting's hard, huh? I had to paint the eaves one time. My shoulders hurt really bad.
He got me free food. Like,
Oh, he paid you in food. That's pretty good. Okay, it says here, printer A, the old one, can print the payroll in 12 hours. Printer B, a better upgrade, can print the payroll in 8 hours. Everyone's going to get their paycheck, and they need to be printed out. Printer C can print the payroll in 6 hours. At 9 a.m., just before the payroll was to be run on the new printer, the power went out for 3 hours. When the power came back on, the boss turns to you and says, if we connect all 3 printers to the computer, will the payroll still be done by 3 o'clock? So while the techie dudes are making the connections, you quickly figure it out. How long will the payroll take? Okay, here we go. So separately, we have A, B, and C. A is a bad printer. It takes 12 hours to print all these paychecks, okay? B was 8, and C was 6. Now they're going to take all of these and they're going to put them together. How long does that take? What should we label that as? How about X? Okay? And so this is how these are always set up. Together over 12 hours for printer A, plus together over 8 for printer B, plus together over 6 for printer C. Adding all those up is going to take one full payroll job. Okay. Now, this is a good question. This is like a 5th grade question right here. It's hard though. What's the smallest number that you can divide 12, 8, and 6 into? 24, good. Took me a little while to figure that out. 24. They all divide into 24. So let's go ahead and we're going to multiply all 4 parts of this equation by 24. So I get 24x over 12 plus 24x over 8 plus 24x over 6 equals, don't forget to multiply the 1 by 24 also. If you don't, it's going to be totally wrong. All your numbers will be wrong. Okay, so let's go ahead and clear out our fractions. What do we get? We get 2x plus 3x plus 4x equals 24. So what does that equal? 7, 8, 9x equals 24. Go to your calculator. Take 24, divide it by 9, and you get 2.6 repeating. So 2 2/3 hours. So let's answer the question. There's 2 questions. How long will the payroll job take? 2 2/3 hours. Will it be done on time? Okay, when did they start payroll? At 9 a.m. and then it came back on at noon. So at 12 o'clock, we want to know, are they going to be done with payroll by 3? Yes, they are. And everyone's going to have a great day. Yay. Whew.